IoT Unplugged. Tune in to the Internet of Things. Hi, this is Christian McCann, editor of IoT Insider, and welcome to our podcast, IoT Unplugged, where each episode will be examining and discussing some of the most interesting and pressing issues surrounding IoT today. The intersection of AI and wireless communications is an exciting one. From the promise of AI-powered spectrum management to the role of intelligent algorithms in managing the increasing density of IoT devices, AI promises to usher in a number of benefits. But it's not all smooth sailing. Some challenges regarding things like implementation of AI and wireless standards and training of the network remain. Yet a bright future for it could exist should these be overcome. But how would that happen? To discuss this, I'm joined by Houman Zarrinkoub, Principal Product Manager at MathWorks. Houman, thanks for joining us today. If you can just start by introducing yourself and what MathWorks does.
Thank you very much. So, yes, my name is Houman Zarrinkoub, and I am the product manager for all the wireless communication products at MathWorks. And what we do at MathWorks, we provide software that enables our customers to design engineered systems, including wireless communication systems. And that's why we are with you today.
Excellent. Well, speaking of wireless communication, our topic will be about AI and wireless communication. And so, just in case anyone isn't familiar, what can you explain to us is meant by AI in wireless communications?
Yes. So essentially, the application of AI to wireless communication is rather recent or new. For example, the standard body 3GPP, responsible for cellular communication, in its latest release, release 18, is introducing for the first time standard-based AI techniques. Now, the community of wireless communication design has two approaches to AI and its future. One of them is that some engineers believe that we should do wireless communication they have been doing, use AI techniques just to optimize and customize existing methodologies. The other group in our community believes that we can revolutionize the wireless communication because of going from a signal based communication. We capture our data as a signal and transmit that to a context based or semantic based communication. We communicate what we mean, and the AI, digital twin, and so on can bring it back to the signal space. So these are two different views of the effect of AI on the future wireless communication.
Okay, well, what issues might there be for integrating AI into wireless systems? As you mentioned, is quite new. What might impede its development or its integration?
Yeah, that motivation for introduction of AI is becoming very clear to our community, meaning that as we went from third generation to fourth generation, fifth generation, and the future sixth generation wireless system and the corresponding similar technologies, the problems that AI solves best became the main bottleneck. AI is known to solve essentially nonlinear and multivariate problems. If things are nonlinear, AI can zoom in on the statistics and decipher nonlinearity. If the number of parameters or variables becomes too much, AI can provide a solution that escapes the knowledge based, human based communication. So, because of the flexibility that introduced in every generation of wireless systems and so many parameters in the 5G and 6G and so on, that is the angle where AI has become a must for applying it to solving the design of the next generation of wireless systems.
Okay, well, you mentioned this flexibility, and obviously AI will have to do a lot with optimization, so perhaps reduction in cost. But can you give an example of, where this flexibility will come in and how the cost will be reduced by this AI and wireless systems?
So the best thing about AI is that essentially there are four phases of design in an AI-based system: data gathering, training, uh, testing, and deployment implementation. Now, the AI systems rely on data, lots of data, and the the onus of design is essentially divided on the training or allocated to the training phase. Training phase is usually offline, and a lot of high performance computation has to be done on the training. But if you train it well, the implementation during testing phase, during deployment phase, is rather simple compared to alternative techniques. So AI brings flexibility in the real time operations of any system it touches. And that's how it essentially reduces cost. Yes. So one of the areas that is AI is very well known for is what we call resource allocation, allocating spectrum and managing spectrum for multiple users, and so on. And again, this is a very multivariate, a very hard problem to solve. Is an optimization problem. If you gather data for previous communications and train it offline, then you can essentially use those information to provide a real-time higher performance for your systems. That's exactly where the effect of the frequency management and handoff problems and all areas related to quality of service of multiple users in a wireless communication systems is applicable to AI.
Okay, well, let's say AI in wireless communications become more widely adopted. What are some of the impacts we could see from its use?
The impact in terms of applying AI to wireless standards is twofold. One of them, I call it strategic impact, and one of them is called tactical impact. So, if you apply AI techniques to wireless communication standard, the expectation is that we can increase the efficiency and customization by order of magnitude, and we reduce the what's known as overhead and waste. Because you know what the promise of AI is. Every system under design has a statistics, and AI using data that represents that system under design will actually cover all the statistical nature of the system and will bypass the stuff that the system will not go to. Whereas the non-AI based system have a lot of waste. We design things that are never used. So that is one of the impacts. Is you design a system that is represented by the underlying statistics, and that can make it very efficient. The tactical benefit is this. Previously, because of the protection of intellectual property, there was no motivation for various players in a wireless communication, the companies, to work together. They compete. Whereas since AI approaches require large data sets, for the first time, we have a completely new way of cooperation between member of standard community, which is about sharing their data. So these are the two elements that makes the AI application very promising.
Okay, great. AI and wireless communications, the effect on IoT. How do you see this affecting IoT? We talked about spectrum management and stuff like that, but I was curious to hear your thoughts on these two.
Every conference that we go to and all the papers, security risks are associated with the IoT are mentioned as the main impediment for large-scale adoption of IoTs in everyday life, right? Because if these IoT devices, these very small, low-power devices, are essentially hacked by unfriendly users, the potential harmful effect of that can undermine their benefits. So AI designs can help with that. We have a potential to make the authentication and real-time risk management more reliable. And as such, we can address these risk concerns of IoT and what is emerging in the lingo of wireless communication as massive machine type communication that's coming in the future. So that's how I see AI making the risk profile more in line with the expectation for IoT deployment.
Okay. Well, I thought so you say the large challenge is security, but I was wondering what are the challenges and solutions for optimizing like a wireless communications network?
So to optimize the wireless networks and support for massive connectivity demands of IoT, the challenge is again threefold. One of the challenges is this. Previously, before applying AI techniques, protecting intellectual property of every contributor to standard, to design, was the main challenge. You don't want to give away your intellectual property that easily. Now we have to add to that protecting the data sources, because if data sources that are used to train AI systems are in the hand of, again, unfriendly users, it may bring the notion of compromise back to the concerns about IoT. Now, the encryption challenges, identification, monitoring, and making sure this adding all these extra protections doesn't essentially jeopardize real-time communication is not a problem. If you add much more levels as overhead, don't you bring the throughput down? Don't you bring the the speed of communication down? That's another challenge. And then another challenge that people in this area have to face is when you have all these machine type communication devices talking to each other, we need to centrally monitor all these connected devices, right? For all kinds of reasons, security, fair play, and so on. And that could jeopardize legitimate concerns customers have for privacy. So these essentially higher level concerns are one of the challenges that you have to deal with when designing wireless communication with AI for IoT.
So, what fields do you see utilizing this AI and wireless communications in regards to IoT?
Yes, the IoT started as connecting everything to everybody and so on. But there is a particular industry and particular area, automotive autonomous driving, that is emerging as a place where the the economic outcome of investing in this area justifies the introduction of that massive machine type stuff. So autonomous driving, in my opinion, is one of the areas that can be put under IoT umbrella, if you like. It has progressed very far. You see all the essentially many electrical vehicles using autonomous driver systems as part of the optional or mandatory use. And these systems essentially need AI because essentially you have to replace a driver by a machine. And the same way driver is very aware of the situation. If a tree is in front, if a bird or animals walks in the way, if a pedestrian comes, if there is unusual changes, the human driver responds to that hopefully in a positive way. We have to program all of that in an AI system. And this has become a mega trend, lots of investment that has put into designing and testing and validating these AI systems. Now, the best thing about this subset of IoT systems, the autonomous driving systems, is as electric autonomous vehicles are deployed and used, they generate data that can in itself add and improve the performance of AI systems. It's a self-learning and self um, augmenting system. So every time you go to every corner, every car turns in real time, you learn about the actual geography of the places that you're driving on, and that data is communicated centrally. And then next time an autonomous system travels there, most of that geometry hopefully hasn't changed, and the system has to respond to very localized in time and space events. And that's very important to see how the progressive and because essentially called the approach to AI known as reinforcement learning is applied to this kind of situations. So that's how I see the IoT having its first steps in wireless communication and AI. Autonomous megatrend is going to drive that application.
Okay, excellent. Well, as you've mentioned, that where you see AI, wireless communications, and IoT, maybe you could just give us closing remarks about the future advancements and growth of AI-based wireless systems. Like, what are your thoughts and opinions on the direction of where it's going?
Yeah, the essential challenges of wireless communication is quality of service, performance, and speed. If you talk to any engineer, they mostly agree with that. So you want to maximize quality of service, maximize performance, maximize speed at the lowest cost of implementation. So I think that AI can touch upon all of these areas. When it comes to quality of service, meaning that you expect a certain quality when you talk to somebody on the other side, and you want the voice quality to be clear, the video to be clear, everything to be real time. The the application of AI right now by many wireless service providers is to make the essentially resource allocation to users optimal. What is resource allocation to users? It's scheduling, allocating bandwidth, and monitoring the channel so you can provide the best quality of service. The other side is performance. If you have a good link, can you squeeze the maximum into the channel and get the most from your available resource? Now, what's going to happen is AI is going to enable very accurate localization and positioning needed. So the next generation of wireless systems know where you are. They're going to send the energy toward you. They're not going to waste it in all directions. And that's why we see these notions of channel quality feedback, beam management, multi-user MIMO, all these approaches of making the performance higher are going to be benefiting from AI for wireless. And the last one, it says using the least amount of resources, meaning computational complexity. And I touched on upon that. If AI is trained properly offline, the online and real-time implementation of AI can be very efficient. And then you get those three metrics of best wireless communication system, the quality of service, performance, and resources, all benefiting from application of AI techniques.
Okay. Well, I think that's a good place to end it. Houman, thanks for taking the time to speak to us today, and I'm sure our listeners will really enjoy your insights.
Thank you very much.
Remember to subscribe to IoT Unplugged wherever you get your podcasts, and don't forget to share with anyone you think would find it as interesting or as informative as you have. IoT Unplugged. Tune in to the Internet of Things.